of course. So, therefore, to make our connection more sustainable, turn off my video and leave you alone with my presentation and my voice. So, okay, in the end of the lecture, I will definitely leave time for a question. So today we will become a little closer to digital technologies. Sorry, I'm just open the chat. If you maybe you something write in chat. So we live in interesting times when change begins. These change are beginning to transform the world around us. The fourth industrial revolution, better known as, transforms our lives. It transforms mining processes, markets through the creation of cyber physical systems. So cyber physical system has the ability to create a connection to machines, people, processes, environment, to a single cyber physical space for the purpose of integration. So the world has entire what has been called the first digital decade. With more data than ever before, there are many opportunities for innovation in the energy system, in the energy industry, in the mining industry, uh, and a lot of work is underway to digitalize in energy. The term digital transformation has come to define how organizations adapt to digital change. Technological development in the field of digital and information technologies will create new opportunities for increasing the efficiency, energy efficiency, and efficiency in processes in some industries. So our lecture focused on the very important topic of digital transformation in energy and all mineral resource complex and the role of competence in the digital transformation. So today and in the Monday, yes, in the first part and in the second part, we will discuss 5 key areas. So, first of all, it's a global energy challenges. Then we go to key trends in the mining and energy sector. After that, prerequisites for digital transformation. Next, the role of digital competences, and the last and Monday is integration of competence and integration of knowledge. So let's start our lecture. The world faces a number of challenges that dictate change in the energy sector. The energy of the world and individual countries have a serious task. Energy must be transformed. Why is this transformation necessary? So, what technologies I need for the energy transition? We will talk about this today during our educational course. So first, let's remember what energy is. So depending on the conversion stage, the following type of energy are distinguished. It's a primary, it's an energy resource extracted from the environment. Primary energy resources are renewable, solar energy, hydropower, wind energy, annual wood and peat increments, geothermal energy, tidal energy, sea currents. Their reserves are constantly replenished. No renewable. Those reserves have no sources of replenishment and are gradually decreasing due to their growing consumption. It's a coal, oil, gas, nuclear energy. And the next step, it's a second, it is or supplied. It's energy carriers received by consumers. Different type of liquid, solid, and gaseous fuels. Of course, most popular it's electricity and the steam and hot water, various carriers of mechanical energy, and the final stage of energy, a form of energy directly used in industrial, in transport, or household processes of consumers. So we know that the world is constantly growing. Um, this growth leads to high energy consumption. And the last 150 years, the main resources of primary energy has changed several times. So it was wood. Um, After wood, we have a coal, but now we live in the area of oil. A lot of forecasts show that the gas will be next. So it is gas that is called bridge fuel, symbolizing what is the energy that can help the world to move to some other energy. But at the moment, there is no common understanding of what energy it will be. So the world can swing towards nuclear power, thermonuclear fusion, or renewable energy sources. Also, the world may move to more difficult to extract hydrocarbon deposits. Um, so many directions. There are many directions. We cannot indicate which of them will be the leader in the next 40, 50 years. So now we live in the area of oil. We expect that from 2040 it will be the area of gas, area of bridge fuel. So if we look at electricity, electrical power station, we will see that change will occur early. On this slide, if we look at the capacity for 2022, we will see that coal is still the leader and gas will the leader around maybe 26, but it just for a decade. By 2035, solar energy will become the leader in installed capacity in the world. But we cannot compare 1 megawatt of gas power plant and 1 megawatt of solar power plant. The maximum capacity factor, the maximum gas capacity factor will be determined by the operator. Yes, it's a man. In solar energy, this coefficient is determined by the presence or absence of the sun. And it is important to understand that there is a difference in percentage between the installed capacity, as you can see on the slide, or certain type of generation and the percentage of energy produced by the generators. As you can see in the examples, the installed capacity of coal and gas generation on the right side of the slide, yes. So installed capacity of coal and gas is half of all installed generators in the whole world. Gas and coal create 16% of energy, of electrical energy, of course. The sun and wind make up 18% today, but still provide only 8% of the total energy in the world, electrical energy in the world. But as we see this change are taking place, and a part of the world pays attention to renewable energy. Another part of the world is still building up gas capacity, coal capacity. Thus, we understand that the demand of the modern world of energy is very great, and demand of the electricity, is very great. It will grow from year to year. So perhaps if the new primary source is not found, the gas maybe will last 16 years. At the same time, the gas bridge turns into a gas slope. A number of scientists believe that we are waiting for a return to coal fuel. But its use will be more clean and environmentally friendly. Possible transition to alternative renewable energy. Okay, so I see in chat some people can hear me. Okay, maybe some write in chat. It's really you can hear me. Okay, just try. Yes, okay, I see you can. So let's go. So, however, disputes over the full transition to these sources do not subside even now. For example, hydropower refers to renewable but does not apply to alternative. It is believed that the economic potential in the world is about 18% utilized. I don't know how, maybe in other country, in China, in some other countries by it, in Russia, this potential is about 70%. So nuclear energy once was a hope for us, for people, but today the world is divided. One part of the countries, for example, Germany, refuse atomic energy. Others, such as Russia, such as China, continue to build and develop new station, new technology in nuclear energy. Okay, thermonuclear fusion is also a hope for humanity now, but there is not a single industrial reactor on the world. Yes, about 8,000 reactors, but they are all research. Perhaps for industrial use, thermonuclear fusion will be ready maybe in 40, maybe 16 years. Yes, also developments are underway at the Large Hadron Collider with research for dark matter and other yet inaccessible forms of energy. So, maybe sometimes we'll be able to use them, but perhaps this will not happen. But we need to live now and count of what has already been mastered. So which of the development parts will be deciphered open. So I see you write in chat fuser. Okay, just writing. Yes, fusion is energy that promise, but at the moment does not deliver. Yes, of course. So the fuel and energy complex, yes, it's a fact. Is an object subject to the influence of four main factors. So, first factors, it's the people. People who ask, give me energy cheaper or more environmentally friendly or give me more energy. They determine where the fuel and energy sector will move in particular country. New technologies in the production of equipment, new technologies in materials also change the efficiency of the fuel and energy complex. Control informatization, which will greatly change the appearance of the fuel and energy complex for the next 15 years, as well as political management. In some countries, the direction for energy is determined by the leader, uh, big leader. For example, in USA, Obama was for renewable energy, and then Trump for coal and oil and gas energy, and now Biden and he's bring back renewable energy. So this determines that investment in which industry go more. And in other countries, the policies is dictated by transnational companies, which in fact dictate how energy should develop. He give you money, give you technology. He develop your country, your fact. So companies offer technology, provide investment for the implementation of these technologies, and shape the image of energy in many countries. Stocks of energy resources are also changing value. New extraction technology, new exploration technologies determine what part of the resources receives today. So we can economically extract, and this affects the decisions that determine how the energy sector will develop in the particular country. However, no matter how the energy is changed, it must follow the basis principle of energy security. It's a very important energy security. Yes, and the energy security is one of the most important components of a country national security. It is a state of security of the country, its citizens, society, state, and economy from threats to reliable fuel and energy complex for energy supply. Ensure energy security is determined by resources abundance, affordability, environmental, and the last, the technological acceptability. So, resources sufficiency determines the physical possibilities of a sufficient energy supply. Economic affordability, the profitability of such security. Environmental and technological acceptability, the possibility of extraction, production, and consumption of energy resources. Therefore, no transformation in energy sector should affect the energy security. This is a key issue for the energy sector of the poor. We have the global rating of energy sustainability uh, in the various countries. So the World Energy Council's Energy Trilemma Index tool from ranks countries on their ability to provide sustainable energy through three dimensions. So, energy security, like on previous slides. So, energy equity, it's acceptability and affordability, and environment sustainability. This ranking measures overall performance in achieving a sustainable mix of policies, and the balance grade highlights how we account to manage the trade-offs of the trilemma, with the A being the best. So, um, for example, in this rating, Russia was in second place in 2014. But now, in 2022, it's at 28th position, as you can see. This is mainly due to the impact of sanction and the focus on hydrocarbon energy. As you can see, for example, China, yes, is also 51st place in this ranking. And for example, the lowest score, it's an environmental component. Okay, so we can add energy consumption, of course, with the amount of services we receive. What is the quality of life? What that must grow steadily. Quality of life, it's a year from year to year, grow and grow. It means that we must consume more services per unit of time. We consume more, and we think that the standard of living is increasing. So this model leads to the fact that all our actions that we perform, we connect with the consumption of electricity, of course. And as you remember, electricity is the second resources, yes? And the primary resources is need for it. You can see that everything we do is related to kilowatt hour. Yes, if we consumption electricity, and even if the devices around us become better, become more efficient, the number of devices is only growing. We have a second refrigerator, we have maybe 5 laptop, yes. So it's devices is only growing, and consumption of electrical energy is growing with this number of devices. So let's take a look at people. They affect the fuel and energy complex, of course, and the growth in consumption that causes a rise in the number of people is threat to energy. The standard of living does not stop, and it's constantly growing in the world. What is the standard of living? Standard of living, well, far for the unit of time, the amount of consumption by an individual is also growing. Today, more than 8 billion people live on the planet. Yes, and the United Nations forecasts that in 2040 we will be 9.2 billion people on our planet. There is always a question, is there a limit on the number of people for our planet? So how do you think? We have some limit. I think the size limit is determined by the availability of available energy. It is energy that can create comfortable condition for life and for emergency of a new life. If we look at the energy consumption of an individual in different countries, for example, in these slides, it's how many kilowatt hour per one person in a year in a simple country. Consumption is very large. A person consumes a lot because the standard of living is quite large. For example, it's in Northern, United Arab Emirates, Sweden, Canada, United States. For one people, it's more energy per unit, yes. And for on the right side of the slides, it's Colombia, India, Indonesia, Philippines, and it's so small for one person energy in a year. And if we look at the last 10 years, so you can understand that energy consumption is very strongly associated with the processes that people generate. If we look at consumption per person, we will two part of the world. Those who try to optimize, invest in energy saving technologies, reduce consumption, it is a division of the world. Over the past 10 years, the number of people who live in cities has also increased, and more countries want to move to post-industrial economy. But we also see developing countries increase the quality of life and energy consumption per person. So as you can see on slide in the graph in the right corner, in 2009, for the first time in the history of mankind, the urban population was equal to the rural population, reaching 3.4 billion people. It is expected that an increased part of the world population will be represented by citizens. That is, the urban population will continue to grow faster than the population of the world as a whole. So we live in the area of Internet of Things, since 2011, according to company Cisco. The number of things in the internet is great as the number of people. And we must understand that 21 billion things communicate in the internet without people, without man. The most modest prediction released from Intel, as you can see on this slide, yes, on 2020, 200 billion Internet of Things, yes, and from Gartner, it's a 21 billion Internet of Things communicating Internet. That's a tenfold difference in the assessment indicates that no one sees the real picture. No one understands what real picture. All these devices require energy consumption, not only for charging, but also for informational transfer. Each of devices wants to send, receive, store, or processes information. The world spends a significant amount of energy for it. So, for example, one of the information technology is blockchain, which implies the use of distributed ledger to create one of the cryptocurrency. And for example, it's Bitcoin, and Bitcoin have his energy chart that says that this technology consume energy like Poland, like Thailand, like Vietnam. Could anyone have guessed 4 years ago the second Thailand in terms of electricity consumption will appear in the world? It did not appear because of new people and processes. Yes, this magic technology related to banking and cryptocurrency. This technology results in consumption about 200 terawatt hours per year. So this does not seem to be very large for other countries. For example, Russia produces 1,070 terawatt hour per year. But Russia, it is in fourth place in terms of electricity generation and electricity consumption. Such technological development increase consumption as a result, increase the burden on the need to create this energy in the first place. So, to date, studies from our colleagues show that $1 of profit in the most common cryptocurrency in the left side of the slide. Yes, as you can see, it's Bitcoin, Ethereum, Litecoin, Monero. So, is spent on energy more than $1 of profit when mining rare earth metals, gold, platinum. Okay, $1 from mining of cryptocurrency and $1 of profit from mining from copper, gold, and other. That is, even such energy-intensive industries as mining cannot be compared with the consumption that is spent in the world on informational technology. And most importantly, every dollar mined in the world costs more and more energy. Yes, and if we look at forecasts for maybe next 20 years, so we will see that consumption is really growing, and the number of countries who reduce consumption correlate with volumes of other countries who try to increase it by the next 20 years. You can see that the biggest growth in consumption is concentrated, for example, on continent of Eurasia, where's Russia, yes, where China, where is India, Middle East. We understand that consumption will grow around us. Our energy in mining need to change to reflect global challenges in the world. We see that most of the energy and materials that the world and especially our continent wants to receive, they will not achieve it on their own. The main part of the support will fall on the Russia energy system, on the Russia FEC. Do we need to prepare now? Do we need to prepare together? Of course. We are on the same continent, we are on the same planet, and we are all responsible not only for the energy on our territory, but for how sustainable our common energy will be in the next 40 years, 50 years. Yeah, and this is very important. So, of course, we start think about it. We can conclude that population growth, increased consumption, scientific and technological progresses, urbanization, environmental and climate change, so economic crisis and the decentralization of the world are global challenges that we pay a lot of attention. So each of these challenges requires a separate answer to those changes that we need. And this change take place, and digital transformation, sustainable energy and energy efficiency, it's answer for these global challenges. So changes have begun to happen in 20. Sorry, just a minute. Okay, yes, this slide. In 2017, a 3D concept in the energy sector was formed in the European Union, which implied three key trends. First of all, this is decentralization. We are moving away from the large generation to end-use generation, and this generation is really getting bigger. Along with this generation, it is necessary to thread regulation and management differently. There is a trend towards decarbonization, a trend towards reducing the environment impact of fuel and energy complex. This trend formed all over the world under the influence of the Sustainable Development Goals, make itself seriously felt. We see more and more countries, companies that are increasingly turning to decarbonization in the energy sector and trying to switch to source with lower carbon emissions. Well, The next trend is digitalization as an established trend that permeates almost all processes in the energy sector. This trend, which links the previous two, that is, we can now achieve significant processes in decentralization, in decarbonization without digitalization. We at the Mining University in St. Petersburg, in Educational Research Center for Digital Technology, noted two more trends in our research. So this is a primary trend of increasing information technology depends of production, transportation, and use of various type of energy on each other. We can't become more efficient if we don't see the processes and don't understand what is happening outside of our field of activity. So if we have change in electricity in the electric power industry, then it's important for us to understand what is happening with the primary energy from which we draw electrical energy. This trend to reduce consumption not only of energy but also of type of resources and materials, reduce the amount of waste and increase the involvement in recycling. Indeed, more and more people, businesses rely on completely different growth points that we were 10 years ago, and many find growth points not in increasing consumption, but on the contrary, in its decline, decrease. And it is involvement-based recycling. This is an established trend that is changing the face of the energy sector as a whole. Under the influence of these trends, and understanding has been formed that digital transformation is necessary as a linking part of all these key changes that we are seeing today in the energy sector. But for the most part, when people say, so what digitalization is, they tend to believe that is some kind of technical transformation. That is a transformation where we change something analog to something digital, or when we translate some information from analog to digital. But this is only the first stage of one of the levels of digital transformation. So what do we mean by digital transformation? Yes, this is a technical transformation, of course. It is starting point, but it is also a transformation of business processes, without which movement is unthinkable. If you have change, you have obtained information, new knowledge is extracted from this information, new knowledge generated changes in the business processes. This is a transformation in regulation, if of not only a separate area process, but in the regulation of entire industry. This is a transformation in the structure, as you can see on the slide, because under the influence of opportunities and technologies that we have on the basis of the information that we generate, collect, on the basis of that knowledge, we change the structure. The transformation management, this management that we have today should be completely different, of course. For example, when we turn to our decentralization, when in the Russian Federation, in the entire unified energy system, which covers 8 time zones, there are little more than 900 power stations, and when you manage a little less than 1,000 stations, this is one approach. Yes, Okay, but when there are 2, maybe 4, maybe 10 million stations, this is a completely different approach in managing these stations. This managing can no longer be carried out by only one person on the basis of their knowledge and competences. It is management that must be carried out together with information that will be embedded in the processes and regulation. So this is a kind of end-to-end transformation that we are talking about at 5 levels. This is a digital transformation. It is this transformation that is necessary for the key changes and acquisitions of those properties that we lay down in the concept of Industry 4.0. And these properties are acquired by both energy facilities and, for example, mining facilities. Accordingly, the key qualities of Industry 4.0, which are obtained on the basis of 5 levels of transformation, relate to the speed of the processes themselves, the transformation, the speed of bringing some new products to market, new service, flexibility in terms of supply communication with the client, adjustment to the client, flexibility in terms of change to responses, to changes that occur in the external market. It is also a quality that should not suffer when we gain speed, when we gain more flexibility. This is a efficiency in which energy environmental sorry, energy, environmental, and economic efficiency are invested, and we do not consider them separately. They act harmoniously. They together as single quality accompany as the work of enterprises and the security that we invest and the security of supply and cybersecurity and the security of our processes that we manage through digital transformation. It is that these key qualities what that we lay down in the changes of the need to change them that we want to achieve. Okay. Um, it is these changes that the digital transformation, for example, for mining enterprises, is telling us the data that comes from equipment, from activities, from processes, enables the shift of digital mining. It is knowledge gained from this data that will lead to collaboration between people, between processes, things, and machines. So data must be extracted, and this is very important, integrated to a company processes. Knowledge born from each state of processes in the physical world should not disappear. They must serve and work to achieve greater efficiency, flexibility, speed, and process safety. Moving to digital mining for digital energy will allow us to be part of this response to the global challenges we talked about earlier. So, but a number of challenges must also become on the road to digital transformation. Okay, I'm just write what you asked me in the chat. I would like for that to be this case. We could revise this later. Just a minute. Okay.
Не отвлекайтесь, Юлий Леонидович.
Okay. Yes, I'm talking about this question maybe later.
It's the question about recording. It's not the question about the lecture. So
Okay, okay. So, uh, okay. So another key challenge is it's coronavirus. Yes. Mm, which greatly influence the creation of key properties. For example, we have some properties and flexibility, for example, is necessary in terms of rebuilding processes. If we look at this slide, we will see that a very large drawdown in consumption was received by countries where most of the economy is built on services. For example, in Russia, quarantine restrictions did not affect very much, but in Italy, in Spain, in United Kingdom, it affected significantly. You can see from this graph that the adjustment and change that were necessary based on the information were not carried out, and most energy companies were not ready for such changes. And along with them, primary resources were not ready for these changes. Yes. Um, at the end of the world, at the end of the year, sorry, the world began to consume less coal, oil, gas, and atomic energy. And the demand of electricity energy decreased. The only positive thing left is only renewable energy source, while a plus can be called a reduction in carbon dioxide emissions. The huge amount of investments that the energy industry has not received will hit very hard in the coming years. Perhaps some of the industries today will not receive such investments that they would like to receive. If it is a very, very big problem for energy complex in the world. The flexibility of our process, uh, the speed of their instructions, and the security of processes become very important. We made an analysis of the current trends that are currently present in the energy sector. We compared these trends with the achievement of sustainable development goals. As you can see on this slide, I think that in many lectures after my, the concept of sustainable development goals has been discussed. Joint development in economic efficiency, social policy, and ecology needs to be implemented today. Most of the sustainable development goals are related to the trends that we see at the moment in the energy sector. When I talk about the energy sector, I'm talking about coal energy, gas energy, electric power station, renewable station, and the oil in general. So, after compare the sustainable development goals with the current trends, we analyze that the risks that took place in the energy sector in 2020. One of the leaders in terms of risk was emergency associated with spread of epidemic of viruses and so on. However, the shortage of human resources, the deterioration of the quality of the characteristic of hydrocarbons, and the growth of hard to recover servers are also among the key risk for the entire energy sector today. I would like to say that the interest interest here was not to analyze one industry, but to see what is happening in general with the energy sector. As a result of our research, we have formed uh, three scenarios based on the approach that we have good, bad, and moderate scenarios. These three scenarios were presented to the expert in order to compare them with those key trends from the previous slides. There are bad scenario called stay home, the moderate stay alone, and the stay affected scenario. So you can see the description of the scenario on this slide. For example, stay home, the maintaining of the isolation of certain groups of citizens, business, and countries, the reducing of consumption of energy, the growing of employment, the high volatility of energy prices, so the deterioration of the ecological situation, the risk of energy huge water and food shortage for certain categories of countries, the growth of social tension in energy poor countries and in countries with a significant foreign trade deficit, the decrease in the world trade in goods and service and physical and monetary terms. So stay alone, for example, the partial restoration of change of international supply of goods, energy, and materials, the instability in the supply of minerals and energy, the still observed investment gap in the infrastructure, the growing need for qualified personnel, the continued deterioration of the environmental situation, and the very, very good scenario stay effective. So the complete restoration of temporarily destroyed global supply chain of energy, materials, and goods in effect to reduce cost and exclude political influence. The creation of prerequisites for a sustainable development of the global energy infrastructure through international planning and financing. The implementation of digital technology in all life cycles of hydrocarbons, restraining the growth of the consumption, the launch of a reliable international system for tracing the origin and replenishment of energy and resources, confirms the level of efficiency and supplied energy and goods, the carbon-free nature. So we analyzed these responses of more than 100 experts from the energy sector, from the research sector, from the educational sector. After that, we conducted factor analysis and decided to coordinate several femoral representations. We became interested in the question of which of our directions will be common for all these scenarios. So we have identified what needs to be developed regardless of the scenario. After analyzing this, we got a set of generalized components that describe most of the data that we collect. We have assigned our names of these components, symbolizing which of the sectors needs to be developed based on these components. The most important key area was the need to digitalize the infrastructure and ensure the reliability of this energy infrastructure. The personal trend is also one of the priorities. So the name of our components accordingly look like this. In fact, they describe the changes that need to be made in the energy sector for sustainable development. These are the movements that need to be done in one manner, development all industries together. These 9 key programs should be developed in the energy sector in order to meet the sustainable development goals for the harmonious development of this complex, both from the social sphere and from the environment. And as you can see in the slide, is program number 1 is effective energy, very important, yes. Then high mining cost, then petrochemical, then processing and recycling, then personal trend, yes, personal program. Number 6, it's a digital infrastructure. Number 7, it's transport ecology. 8, carbon footprint. And number 9, energy infrastructure investments. So, digital technologies play an important role in this development. When we invest in digital technology, it means that we are investing in achieving the sustainable development goals. The Russia Federation last year, in 2020, despite the pandemic, yes, in 2020 it was a pandemic, released its report to the United Nations. There was the role of digital technologies in achieving sustainable development goals was very strongly emphasized. Energy companies, mining companies, oil and gas companies that invest in digital technologies and achieve their goals have been represented there. When we talk about digital technologies, for the most part in the Russian Federation, we divide them into several key blocks. So I will highlight only 6: big data, predictive analytics, artificial intelligence, industry 4.0, modeling tools, virtual reality, augmented reality technologies, distributed ledger, and industrial Internet of Things. But when we get to a single industry, this set of technologies begins to divide into many. So this set of technologies is starting to divide into many, but we understand that all these technologies live of information and live of energy, which plays a very powerful role for the mining industry. Why? Because any devices that transmit, stores, and process information is made of the materials that we get from the earth. As mentioned earlier, more electricity is currently generated from gas and coal mining, as most of the devices on which the energy transition is based are also made from materials that we get from earth, from a mining. There is a seriously threat that the mining and processing industry, due to its inefficiency, may become a constantly for digital transformation, not only in individual industries, but in the world as a whole. Since digital transformation concerns not only energy and mineral resources, but also concerns the economy and social sphere. It is important to understand that if we do not make the mining industry efficient, then we will not make digital transformation effective in general for the world, for the big industries, for the social sphere. And this is a very big problem for the world. According to one of the studies for our colleagues from the University of Aachen in Germany, who conducted research on what digital technologies have developed, for example, in the mining industry in recent years. So we see that indeed the progenitor of all digital technologies of today is automation. As you can see, it's a big cycle. Automation as the basis of Industry 3.0. It is also the foundation for Industry 4.0, because the transition to Industry 4.0 is not possible without going through Industry 3.0. Indeed, only after automation are we seeing the emergence of artificial intelligence, machine learning, and the Internet of Things, and some other. These are technologies that are related to each other, but very strongly related to the areas of automation. If we look at the right heat map, okay, which tell us where and in the what key processes of value creation, which of the digital technologies were used, we can see that automation is applicable in almost all areas, in all key processes of value creation, data creation in real time. It can also be noted that digital technology are practically not used for the educational sphere, and this is a essential fact that we'll pay attention to in the second lecture on Monday. So when we talk about energy supply, in the energy system, in the energy supply for enterprises, for the mining, for the oil and gas enterprises, for the mineral resource complex, the range of technologies here is also quite wide. We conducted this research at the mining university. We tried to match technology with the effects where we want to get, because wherever we talk about the application of technology and information, we want to see the effects. So in our study, we really tried to compare with digital technologies for energy supply, and the electric power industry will lead to certain effects. Key technologies are not yet fully available today, which means that it's necessary to invest in them. As you can see, this technology, it's orange for demand transport, active adapted networks, intelligent power equipment, drive development, blockchain and smart contracts, digital twins, and some other. Yes. Key technologies are not yet fully available today. Also, most technologies are not only internal processes technology for enterprises. They are end-to-end technologies that can be applied outside the electric power industry. And this is important. Yes, in our course we see some of these technologies, not all, but some of these technologies we see in this in lecture our teachers. Okay, so the changes that are currently related to the electric power industry are compared with the smart grid. This technology originated in 2003. which links the entire power industry into a single complex. The smart grid is riddled with a map from IEC. IEC is the International Energy Commission that shows how from the lowest level we connect to the highest level of the markets. On the right side of this slide, you can see the 4 key technologies that permit everything are telecommunications, security, energy management, and power quality. Naturally, all changes revolve around energy saving. This is a very important why smart grid connect with energy saving and sustainable development and sustainable energy. This map is inherent only for the electric power industry. So you need to understand if you make only the electric power industry smart, intelligent, but at the same time leave everything stupid in the chain, starting from primary energy resources, ending with the transportation of related resources, gas, heat, oil, and other energies, we will not achieve the necessary effects that we want. It is necessary to make a unified energy system, which will be made on this basis of information where digital transformation plays a very important role. So, this concludes my first part of the lecture. Remember, my second part of this lecture will be in Monday on the next week. So, I promise to leave time for a question. You can write the question to the chat. In this chat, in Telegram chat, you can try to ask a question by voice, but we have so many people in our chat, and I think voice is a not good idea. Maybe so. We will be in digital contact with you almost until the end of June. Yes, during the all our course, educational course. So any questions that comes to you later, you can write me or maybe Anton. Okay. So that's all for me today. If you have some question, please write. Okay, I see this question. It's question for Anton about our course about Shuttle. Thanks for fire. I see the. Oh, sorry. I see the raise a hand. So you can. Okay, thank you for your attention. Oh, I see some question. Okay. Okay. So, as we saw with the case of the Bitcoin, emerging technologies can modify the worldwide energy scenario. Is any idea of a similar emerging technology? Um, yes, we have some idea. We have some paradox. We talking about this paradox on the next lecture. Okay, yes, some technology can increase consumption. Some technologies can help us decrease consumption. Some technologies can erase consumption, and we have some model, yes, who will win. And this is very interesting research vector, because we do not understand how many devices, how many energy consumption for the information we see in our day and we see in the future. In the second lecture, we're talking about how the information can help energy saving. But today we see how technologies for information not help for energy saving. He help for increase energy consumption. Yes. So we go to talk about this topic in the second lecture, of course. Okay, small model reactors. Yes, it's one of technology for very important for Rosatom. It's a company who built an atomic station in Russia and other countries. But small reactors, it's small reactors. We talk about some energy, some power plants which help for the whole world. Small reactors, it's only for one company. For example, in Russia we have a free project for the small reactor, atomic reactor, for the consumption for mining enterprises and the oil and gas enterprises in the Arctic. Yes. Thank you very much. Have a nice day, have a nice week, and have a nice holidays. What about solar panel energy production? Oh, yes, this is very interesting things. But in the end of the second lecture, we talk about ROI, energy return on energy investment. Some solar panel energy production have a nice model for some region on our planet, but also for the whole planet. This is not the future. This is connect with help for bridge fuel. We have a bridge fuel. If you have solar panel, bridge fuel have some maybe longer time. Yes, if you don't build solar plants, don't build renewable energy plant, we have very small bridge fuel, only 30 years. If we start build renewable energy solar plant, we have bridge fuel some maybe 40, 50 years. Yes, but solar energy, it's not a bridge for us, for our planet. We have some technology, solar energy in I'm just forget how this word on English. Sorry, just a minute. In the space, yes, solar energy in space. But this is the future. Yes, we need to maybe in 15 years we see is solar energy in space. We translate this energy from space to Earth, but this is the future. We need bridge fuel now for next 30 years. Okay. Yes, you have access to the slides. I ask the Anton in we have some folder in our space, and you can go and see our presentation for the first lecture and from this lecture and all lecture from our teachers. After lecture, he sent me his presentation, and I or Anton give you a presentation in a folder. Okay. Okay. So, goodbye.
Thank you, Professor, and we will see you next Monday. I will send you links through the Telegram group on Friday, and possibly on tomorrow or on Friday I will give you the link for the cloud storage for the lecture materials as well. So have a nice weekend, and bye everyone.